Hello friends, today we are going to solve another interview problem, that is print all subarrays using recursion. So we have given an array and we have to print all the subarrays. Okay, so subarray is nothing but the part of array which is continuous, and uh, the length could be from 1 to the array size. Okay, so if we take this example, we have array 1 2 3 4. So subarray is 1 1 2 1 2 3 1 2 3 4 2 2 3 2 3 4. So if you see, it is all continuous part, 1 2 2 3 3 4 2 3 4, right? So yeah, this is the subarrays are different from subsequence. In subsequence, the elements from the array not necessarily should be continuous. Okay, so earlier in another video we have solved this problem using non-recursive approach, but today we are going to solve this using recursion. Okay, so let's read through the problem and take one example. So given an array, write a recursive program to print all subarrays. And if we take this example 1 2 3 4, so 1 2 1 2 1 2 3 1 2 3 4, and then starting from 2 2 3 2 3 4 3 4 and 4. Okay, so so in recursion, it is quite similar as non-recursive approach. First we'll fix the starting point. Okay, so if we have 1 2 3 4, first we fix the starting point and create one subarray of size 1, so that is 1, so just 1, and then we'll iterate rest of the elements and keep appending other elements one by one, and every time we append a new element, next element to the subarray, we'll print the subarray. Okay, so first we'll start with 1, then we'll add the next element. So now my subarray is 1 2, so we'll print that. Now we'll add the next element, so subarray would be 1 2 3 and then 1 2 3 4. So we fix the starting index to 0, so that is this, and subarray is equal to 1. Iterate till end, and during iteration we'll keep appending the elements to the subarray and print it. So we will print 1 2 1 2 3 1 2 3 4. Now move the starting index to 1 and subarray 2, and repeat the same process. During iteration we will print 2 2 3 2 3 4. So basically we fix the index, print all the subarrays, right, which starts from the fixed index, make a recursive call. So this is important. So once we start with 1 and we print up until here 1 2 3 4, when we change the starting index, we'll make a recursive call. Okay, so let's go to the blackboard and understand this. 1 2 3 4. Okay, so let's say our recursive function is print, so int and starting index, start index, and array. Okay, we'll write the base case here. So we'll fix the starting index. So first time we'll call this function, we'll call with 0 and then array. So we'll start from 0. So here we'll iterate from for I is equal to start index to the array size n, and let's say we have subarray, let's call it as SB, and we have subarray, and we'll keep appending to this subarray. So SB plus ERRI. Okay, so we are going from starting index to the end, adding one element at a time to our subarray. Print that right, and then make a recursive call. Let's call it print SB. So print SB, and then starting index would be start index plus 1. So we are now moving the starting index to 2 and make a recursive call. Okay, and in the base case, when this start index reaches to end, right, return. Start index reaching to end, that means the last, so we can print the last element. That would be the only subarray in this case it's 4, and then we can return. So let's go back to our problem. So here I'm assuming n is equal to length minus 1. We can also do if we reach to the end, so we know the index is from 0 to length minus 1. So if we reach to the length, that means we have already processed the array, return that. Okay, so this is our recursive function. So we are starting, the result is equal to, right now it's blank, and this is our current index. So current index is nothing but a start index. Okay, so we go from start index to the end, append one element at a time to the result, print the result. Okay, and once we are done with this loop, that means we are done with 1 2 1 2 3 1 2 3 4. So we need to change our starting index, so we'll add 1 to the current index and make a recursive call. Okay, so yeah, now we can run this code. So we have 4 6 8, and now if we run, what happened? Let me run this again. Yeah, so 4 4 6 4 6 8 6 6 8 and 8. Yeah, so this is how we can solve this problem using recursion. We can mark this problem as completed, and yeah, visit our website tutorialhorizon.com for more interesting problems. Create your account on our website, and you can track your progress by seeing how many problems you have completed, how many problems are remaining. So it's a nice stats which using which you can track your progress. Okay, so yeah, we'll see you guys in the next video. Bye bye.